Today, we're diving into a digital crime scene. Seriously, it's a story about a massive system failure, a team of totally baffled engineers, and a hidden culprit that brought a multi-million-dollar company to its knees on the most important day of the year. Okay, so let's set the scene. Picture this. It's Black Friday, the biggest sales day of the year. And the victim? The company's real-time analytics dashboard. This was the tool they relied on for everything, making split-second decisions, and when it went down, well, total chaos. You have to understand, this dashboard was the company's entire nerve center. It was constantly crunching click data, showing what was selling, what wasn't, where to push ads, the whole shebang. But under the sheer weight of Black Friday traffic, it didn't just get slow. It completely disintegrated. And here's our first piece of evidence. A system that normally spat out answers in a crisp 200 milliseconds was now taking a disastrous 45 seconds to respond. That's not slow, that's broken. Imagine trying to drive a car where the steering wheel only works after a 45-second delay. That's the kind of crisis we're talking about.
And then there's clue number 2, which was even scarier. Every single server running their Node.js app was pegged at 100% CPU. Just completely redlined. They were burning hot, spinning their wheels like crazy, but accomplishing almost nothing. The whole system just started failing health checks and getting into this useless cycle of restarting itself.
But this is the symptom that was truly baffling. At the very heart of Node.js is the event loop. It's the whole reason Node is so fast and efficient. A healthy one is lightning quick, but theirs was lagging by up to 800 milliseconds. For Node.js, that's not just bad, that is a death sentence. It meant the entire application was just frozen in time for huge chunks of a second.
So you've got the engineering team in full-blown crisis mode. Where do they even start? Well, like any good detective, their first move was to round up all the usual suspects. But yeah, they were in for a major surprise. Right away, the team was thinking blocking I/O. Something external must be holding things up, right? Maybe the database is overloaded or some network call to another service is timing out. This is pretty much page 1 of the playbook for debugging a slow Node app. But as they started checking things off the list, the mystery just got deeper and deeper. The database? Nope, it was totally fine, responding super fast. Network traffic? Yeah, it was high, but nowhere near the system's limit. Memory? They had tons of it to spare. Every single one of their prime suspects had a rock-solid alibi.
And this is the exact moment the case went from being a routine outage to something truly fascinating. If it wasn't the database, and it wasn't the network, and it wasn't a memory leak, what on earth could possibly be causing 100% CPU usage and bringing the event loop to a grinding halt? What was this hidden villain hiding right there in plain sight?
It was this. The whole thing came down to a single, humble, synchronous function call, JSON parsing. See, the analytics service was getting these absolutely massive JSON payloads from the front end, some up to 5 megabytes. And just parsing that text, that one operation repeated over and over again, was the sole cause of the entire catastrophe. Now, to understand the motive here, why this one function could commit such a crime, we have to look under the hood of Node.js itself. See, Node isn't just one thing. It's really a secret partnership between 2 absolute giants, Google's V8 JavaScript engine and a C library called libuv. And understanding how they split up the work, well, that's everything. Okay, here's the best way to think about it. V8 is the brain. It's the part that actually executes your JavaScript, thinks through all your logic, and runs your code. It's incredibly smart. But, and this is key, it can only do one thing at a time. Then you have libuv. That's the nervous system. It handles all the waiting for files, for network requests, for database results. It's the absolute master of handling things in the background.
And that brings us to this idea of synchronous work. This is V8's world. When V8 is busy running a function like JSON.parse or crunching through a complex loop, it is 100% focused on that one task. It cannot and will not do anything else until it's finished. The entire world, including our friendly nervous system, libuv, just has to sit there and wait.
So here's exactly how the crime went down, step by step. V8 gets handed this giant 5 megabyte string of JSON. It immediately starts parsing it, which is a purely synchronous, CPU-heavy job. Now, while V8 is chugging away at this, the main JavaScript call stack is never empty. And that means libuv, our nervous system, never gets a turn to run the event loop. It can't check for finished database queries, it can't fire off scheduled timers, and most importantly, it can't accept any new requests from the outside world. V8 was literally starving the event loop. So once the team finally figured out what was going on, they weren't out of the woods yet, not by a long shot, because now they faced a totally new challenge. How do you actually fix this the right way? Knowing the problem is one thing, choosing the right solution from a bunch of complex trade-offs is another. They basically had three options on the table. They could try to optimize the parsing itself with some kind of complex streaming parser, but that's really hard to get right and super bug-prone. The naive fix, which they'd actually already tried, was just to throw more servers at it, which obviously didn't work. The correct architectural fix was offloading, moving that heavy CPU work somewhere else entirely. But that meant adding new pieces of infrastructure. And here's a mental trap that so many developers fall into. They think, oh, I'll just wrap this slow, synchronous function in a promise, and poof, it'll be non-blocking. But it doesn't work that way. As this quote says perfectly, it doesn't make it async, it just pushes the same blocking work to a little later in the event loop. You're just delaying the inevitable freeze. So, how does this incredibly painful investigation give us all a new, better mental model for building high-performance Node.js services? Well, it gives us a playbook, one that can actually save you from having your own Black Friday disaster. Here it is. The right way to think about Node is that V8 is the conductor of an orchestra. It's fast, it's lightweight, and its job is to orchestrate things, not to play every single instrument. The heavy lifting, all the I/O, that belongs to libuv. So before you write a single line of code, you have to ask, is this task CPU-bound or I/O-bound? If it's heavy CPU work, it simply does not belong on the main thread. And, most critically, you have to monitor your event loop lag. It's the smoke detector for this exact kind of fire. So what was the ultimate fix? They completely re-architected the flow. The web servers, the ones talking to users, now did almost zero work. They would just grab the raw data and immediately drop it into a message queue. That's a pure I/O operation, which libuv handles beautifully. Then, a completely separate fleet of worker services would pull messages from that queue and do the heavy JSON.parse work, totally isolated from user traffic. Brilliant. And all of this brings us to one final critical question for you to think about. Are you absolutely sure that your beautiful asynchronous I/O-driven service hasn't secretly become a CPU-bound monolith over time? Are you positive there isn't some hidden villain like JSON.parse lurking in your own code, just waiting for your biggest traffic day to strike? The answer, my friends, is in your metrics. That event loop lag will always tell you the truth.